Welcome all of you. In this video, you are going to learn about multi-level inverter. Multi-level inverter. First one basically voltage source inverter. What is a voltage source inverter? The voltage is a constant. Current is a variation with respect to the load. Constant voltage, that is called a voltage source inverter. Okay, then this is a voltage source inverter. It has the generally classified into the single phase and a three phase voltage source inverter. Then say single phase. Single phase means here is a positive and a negative pulsating type of the DC. So positive and a negative. It will going to produce. Okay, two level and the three phase voltage source inverter. It's a three levels. So three level like it is going to develop. What is the limitation of that two level and three level voltage source inverter? If I have look, there are the two major limitation. One is a high voltage stress. The stress is happen on that one. The switch high voltage stress is produced. Another one is a high total harmonics distortion. So these two is a factor is making disturbance on that two level and three level voltage source inverter. Then what to do? How to you will going to eliminate this high voltage stress means you will going to use the soft switching technique, or you can you are studied about the snubber circuit. Okay, like about the or another name it is called resonant converter. So this type of soft switching technique used to avoid the di by dt as well as dv by dt. The next one is here. Another one of the major factor is the total harmonic distortions. The harmonics distortion you will going to eliminate it with help of the filter arrangement. It is used to you will going to do. So this is a limitation of that a single phase and a three phase basic voltage source inverter. Then how to overcome this measure of the limitation high voltage stress and total harmonics limitation means you can go for that multi-level inverter. Majorly the multi-level inverter is used for that high power application you will going to use for that this type of multi-level inverter, high power high voltage type of the applications. See, this is a major limitation of that high voltage stress and the total harmonics is you will going to eliminate it. Another one is the output waveform is a pure sinusoidal waveform you will going to get. Another one is the distortion level is a harmonics distortion level you will going to reduce in the multi-level inverter. So this is a speciality about multi-level inverter. If I go for that one this multi-level inverter, yes, to reduce the voltage stress level, okay, you will going to reduce this multi-level inverter is a and one more is a THD value, total harmonic distortion. It is a classified into three types: flying capacitor, diode clamped multi-level inverter, cascade multi-level inverter. There are three types. And the flying capacitor and the diode clamp multi-level inverter also the same limitation is there. One of the limitation is called a high voltage stress is produced. So this stress as usual for that resonant converter, or another name it is called a soft switching technique used to you will going to eliminate it. Okay, then okay, this is a problem. Then cascade multi-level inverter. So cascade multi-level inverter means more number of switches you will going to use. Cascade means it's called a series connection. So more number of switches is used to you will going to drive the circuits. So it does not require any transformers. To obtain the nominal voltage, an additional DC sources, okay, DC sources only needed, and magnitude components like it will going to act as the DC source. It is act as the transformer methods. Okay, it is a DC sources is needed. Okay, this further it will going to develop about boost. Okay, cascade multi-level inverter like the research is going on. Okay, so that one also boost cascade as usual similar the same cascade multi-level inverter as usual number of switches is needed more. And finally hybrid inverters. So this is a so far we are going to develop about inverters. Then we'll go ahead under the multi-level inverter few more detailed discussion. So it is a reactive power compensation. Okay, and high power and high voltage application this multi-level inverter is used developed especially. And you have see that one the waveform you will going to get the pure sinusoidal waveform it will going to get. See, the total harmonic distortion level also reduced. So level is inversely proportional to the harmonics. So whenever you will going to increase the level, the harmonics level is reduced, distortion is reduced. So okay, distortion level is reduce. That is one of the major plus point. So power industry application you will going to use. Why the power industry application? Because it's a high power device, high voltage application it is going to use on that one. Okay. Single switches is a very less voltage, but a seriously connected switches to achieve for that high power and high voltage achievement. Okay, so it doesn't use any transformer, seriously connected switches to achieve for that high voltage and high power. Okay, high power. Okay, then number of level is inversely proportional to the harmonics. So if you want to reduce the harmonics, what you will going to do? So increase the level of the your multi-level inverter. So 3 level, 5 level, 7 level, 9 level. Okay, like you will going to increase the level value 25 levels. So like you can increase. See here one of the one of the formula switches, number of switches. If you're going to increase the level, automatically the switches number of switches is increase. So level is increase, the switches is increase, the switch number of switches is increase, and then you will going to get the pure sine waveform. You will going to get the plus point. So due to the increased number of the switches, the cost values increase. Okay, and then here if have see for diode clamped in first two method diode clamped, another one is a flying capacitor. You will going to use the for the capacitors. The number of capacitor is used. So there is a number of capacitor it is you will going to use for that one. You will going to control the voltage stress. So number of capacitor you will going to use. So how do you connect it on the capacitor? Capacitor is you will going to connect it across to the source side. So source side you will going to connect it. For example, DC source, DC source. Okay, across that one DC source VDC, there are two capacitors connected. Means the total VDC is divided into the two. Okay, the total VDC is divided into the two. Suppose see here, yeah, this is a DC source, DC to AC converter, DC source. Here is a capacitor is used. How many capacitor is used? Either the two capacitor is used or four capacitor is used. If it is a two capacitor means this VDC is divided into the two, half. It will going to divide it. Suppose four capacitor is used means see that one here is half. It will going to divide it. Suppose four capacitor is used means 1 by 4, 1 by 4, 1 by 4, 1 by 4. So like it will go to the voltage is divided. So it will going to divide the voltage. So this dividing the voltage to you will going to what is advantage? Voltage stress of the control. So stress level of the switches it will going to reduce. So you will going to control. The next one, so voltage in the capacitor is increase. So across the capacitor is connected across the DC source. So voltage in the capacitor values it will going to increase. When it will going to increase to you will going to harmonics level content you will going to decrease. So decrease the harmonic level content. So THD is one of the total harmonic distortion is undesirable, okay, unbearable. So that one will going to concentrate it. So increase the number of level to decrease okay, decrease the total harmonic distortion. That one we were discussed in the last slide. So level is increased to inversely proportional to the harmonics. Okay, then the deviation is harmonics. It is if you going to harmonics level is coming, and then it will go to output waveform is come on the deviations. Okay, so you can't to if your harmonics level is increased, then your desired value you can't to achieve. Another one is your harmonics level always less than the 5% of the total harmonic distortions. It has the IEEE standard also. It will going to suggest it. Then you have see that one single phase also you will going to okay you can develop the develop about the level inverters. I will show you in forthcoming slide. So two level multi okay two level inverter, multiple level inverter, and three level okay inverters. So what is a two level? See that one plus minus. So pulsating of that one. So here what is a DC input and then AC output? It is the AC is coming on the pulsating type of the waveform it is coming. So here is a 0 and a positive voltage, and then here is a minus voltage. So here you have see that one this type of the waveform. Okay, this is a one cycle and then the cycle is a repeated. So positive negative like it is going. So this is about that one plus voltage and the minus voltage. So what about here? Three level means, see here, three level means so positive, and after that 0, and after that here. So like about that level, it is a divided 3 point, it will going to come. So it is a 3-phase inverter. You are going to see, you have noticed about this type of the changes shifted. Okay, so level is inversely proportional to the total harmonics distortions. So level is increased to increase. You have increased the number of levels. So for example, 5 level inverter, 7 level inverter, 9 level inverter, 15, 13, 25, 49. When you have you will going to increase that one, your harmonics level is a decrease. So level is level is inversely proportional to harmonics. It will going to decrease that once if you have increased the level. So if level values of high, what about the level of value? So you will go to pure sinusoidal waveform as well as near to the desired waveform. You will going to get it on that one. Okay, and it will going to reduce the first fundamental harmonics level. It will going to reduce, and 11th harmonics also it will going to eliminated by the symmetrical waveform structures. Okay, then voltage source inverter, single phase voltage source inverter also you will going to develop about that one plus voltage, 0 minus voltage. But previously you have noticed this type of the waveform only single phase voltage source inverter. If firing angle is changes to, you will going to develop about plus V, 0 minus V. So like you will going to develop about the waveform. Okay, then high switching frequency only it produce. Okay, that a multi-level inverter they are using for that high switching frequency, and it will produce for that a minimum ripple and a high quality of output voltage and output current is coming. So this multi-level inverter is they are using for that high switching frequency, but a single phase inverter switching frequency is very less. So multi-level inverter switching frequency is high. So due to the advantage, what is that one? Minimum ripple and then high quality output voltage and output current. So two level inverter, that means a single phase inverter, it is not suitable for that one. So not suitable for high power application. Single phase inverter is not suitable because it cannot operate on the high frequency. It cannot be operate on the high frequency. Suppose you are increase the frequency on the single phase inverter, what will happen? Switching losses also increase. If you are going to increase the frequency, okay, and the switching losses also increase. So it's a problem. So you know the switching frequency of the transformer, particularly whether you are noticed or not, electronics project, when you have a look on the electronics project, there is a transformer is there. The transformer name is, it is called a high frequency transformer. High frequency transformer. If a high frequency transformer means the components, total component board size is reduced. Okay, the total component board size is reduced. So that is a specialty about that high frequency transformer. Okay, coming to that one. Okay, so two level inverter we are not use for that high frequency. If we are going to use high frequency means switching losses also increase. So that due to that this constraint we are going to stop about using for high frequency for that two level of the inverter. Okay, high power application why you will going to use for that multi-level inverter you will going to use. So how do you going to use means you will going to use for that okay, number of switches is connected in seriously you will going to connect it. If you will going to try about that is a single phase inverter means, suppose single phase inverter, two level inverter you will going to take for that seriously and parallelly connected, and if you are going to try means what is the problem is coming. So series and problem is associated. So that is a problem again. And a few more points we're going to discuss about. Multi-level inverter is a switch reactive power compensation device and high voltage high power level because it control the device stress. Yeah, it's a much better. So voltage stress is reduced as well as harmonics level also it is reduced, and it will going to increase the number of the voltage level in the output. Yes, so what is that level? So 5 level means 5 level in the output side of that one, increase the level of the output. Okay, it doesn't use any step of transformer, it is not used, but the output voltage is high voltage you will going to get. Okay, how it is going to get means, so seriously connected number of switches. So still it is, yes, it is a produce at high output voltage and low harmonics content. So this is about the plus point of the multi-level inverter. The number of output levels, if you want to level is increase and one okay harmonics level content is a decrease. So each capacitor charges is denoted. So capacitor voltage is equal to okay V divided by M minus 1. M for that number of levels you will going to substitute. So m is the number of levels. Em is equal to v divided by 5 minus 1. So level, for example, 5 levels means, so 5 minus 1, 4, v divided by 4, that is a capacitance. So capacitance you will going to use number of the capacitance charges values. So number of the levels, okay, number of the nodes, okay, it is a m is equal to n. Okay, so see, this is one of the single phase inverter. So previously you have seen about this type of the waveform is produced for that a single phase inverter. Okay, it is a pulsating type of the DC waveform, but it is a AC. How do you say AC means? It's a center line is 0 and this is a positive voltage and this is a negative voltage. So for positive 100, negative 100, so it is a continuously it is a produced. Okay, so here is it possible for that is a okay step size means? Yes, it's a step is a possible. See here, okay, plus 0 and then minus, it is a step is created. Level inverter triggering, how to trigger? You have that one switch number 1 2 3 4, then switch number 1 to 2 is a what is that one 60-degree angle delay. So it is also operate on the left slash and the right slash mode 1 mode 2. But here what about that one? See here so 60-degree angle delay, 60 degree T1 to T2 60, T2 to T3 60, T3 to T4 is a 60-degree angle delay. So where you are the same method you are used means 3-phase inverter. So 3-phase inverter angle delay between one switch to another is a 60-degree interval. The same method they are used. So level inverter triggering you are going to achieve. Okay, next we go ahead on the types of the multi-level inverter. The multi-level inverter is classified into the 3 types. One is a diode clamped multi-level inverter, or another name is called a okay neutral point clamped multi-level inverter. Then second one is a flying capacitor control implicated cell inverter, or another name is implicated cell inverter. And the third one is majorly you know that one, these two is a same voltage resistance problem is coming, and the third one is a cascade multi-level inverter. Okay, this is a 3 diagram, that's all. Okay, what is the diagram? First one is a okay diode clamped or a neutral point clamped inverter, multi-level inverter. Another one is a flying capacitor, and this is a cascade multi-level. Actually cascade multi-level inverter means see here, this is a inverter 1 and 2, inverter 3 inverter DC source and AC output is produced. Okay, one to another is a cascade seriously connected. So see that one, this point is their output. Okay, and this point is they are going to connect it to the series with the second one. Okay, here is they connected, and this is a point they are taking and connected to here the point, and this is see like you will going to increase the number of level. Okay, they are developed versions. What is a developed version means? The boost converter is used. You already studied about the boost converter. So DC to DC, what is the purpose they are used? Okay, here is the output of the DC converter. It is a high voltage is a needed purpose they are going to use for one boost converter. So you need not to draw about boost converter. So DC source and then inverter. So how many inverter? 1 inverter, 2 inverter, 3 inverter they are used. 3 inverter connected in seriously connected, or it is called a cascade connections. That's all. This is about multi-level inverter. Very simple cascade connection of the multi-level inverter. The next one is a okay diode clamped, or another name is a neutral point clamp circuits. See here is this DC source. Across that one there are 2 capacitor is used. The capacitor point is a okay, this is a neutral point. So here is neutral point is there. Okay, leg number 1 as usual, leg 3-phase inverter, leg number 1, leg number 2, leg number 3 leg is there. Okay, in the leg, okay, here is a neutral point, and a neutral point here is a here is there are 2 diode is there. So 2 diode, it is a one diode is connected to here, another diode is connected to here. Similarly second leg, okay, diode, and third leg diode. So that one only connected, this point is not connected. This is a center point. It is as similar to the 3-phase inverter. A phase, B phase and C phase is brought out. See here how many leg is used? 3 leg is used. 3 leg is used. Each leg, okay, it is a center point. Okay, how many switches are used? You have look at the switch number 1, switch number 2, okay, switch number S1 dash, switch number S2 dash. So when this one is on and this one is off, Okay, vice versa. When this one is on means that one is off. So like about that one, it is operated. Similarly, these two switch also same similar method. When this is on and this is off, okay, and when this is on, this is off, like it will going to operated about that one. Okay, so this is about the leg 1, leg 2, leg 3, and coming here also this same method of the four switches is used. Okay, center point is the same, phase 1 is connected. Between the two switches, what is used? Capacitor is used. So instead of the diode is replaced, two diode is there. So two diode is seriously connected, and connecting to this point, the diode is replaced into that capacitor. That's all. This capacitor name is called flying capacitor. This capacitor name is called flying capacitor. So that's all. Okay, this is only one phase is drawn. Similarly, you will going to draw for that. Okay, two more leg you will going to draw same similar. So extended the line, and similarly leg 2, leg 3 you will going to connect it as similar. So this is about that three type of the multi-level inverter. What is the difference between these three types? You have look it. So what is the differentiation? Small differentiation is giving on that one. So first one is a diode clamped inverters. So it is used in that three level inverter. Yes, it is used on that three level. Okay, and then this flying capacitor is a recently developed one of the topology, and a basic and well known topology is a cascade multi-level inverter. So this is a neutral point. Okay, the mid voltage level was defined as the neutral point level. So mid voltage is the level was defined by the neutral point levels. Okay, here is a flexible control, a modular design. Okay, it is a flying capacitor. This is a cascade bridge multi-level inverter. So voltage booster function, it is going to use helpful for that one. Here is capacitor is connected. The capacitor is connected to the near to the source voltage. Okay, for that one having higher voltage purpose. Okay, here is used for the both single phase and a three phase conversion. You will going to use for that cascade multi-level inverter. You will going to use single phase conversion and three phase conversions. So this is all are used for that high power multi-level inverter, majorly high power applications. Okay, another one is a medium voltage applications you will going to use. Okay, based on that one, the switches and the diode rating is increases. So it will go to several megawatt application you will going to use. So capacitor you will going to you connected across the source side. Okay, float with respect to the earth potential, it will going to float. So at least three voltage levels are required for that multi-level inverter. Three voltage level is needed at least. Okay, a few more of the point is given. Okay, diode clamped inverter. So what is that one? M minus 1. M is a number of the level. So for example, 5 minus 5 level inverter, 5 level multi-level inverter means 5 minus 1. What is the answer? 4. 4 capacitor on that DC bus is needed. So DC bus is across that one. So 4 capacitor is you need to connect it. So in that point, so 4 capacitor you will going to connect it. So 2 in that point and 2 in this point. Okay, central is a neutral point, you will going to connect it. Okay, the next one. Okay, DC. So DC is equal to VDC. VDC divided by 4. Yes, 4 capacitor, it is each capacitor VDC divided by 4. So each device across that voltage stress is minimized. So 4 capacitor it is used to, you will going to minimize the voltage stress. Okay, level is for example 5 level means 5. Okay, 5 minus 1, 4 capacitor is used. How many switches is needed? For example, how many switches is needed for the circuit? So 2 multiply m minus 1. So 2 multiply m for that level. So yeah, 5 minus 1 means 4. 4 minus 2 means 4 multiply 2 means 8. So 8 switches is needed. 8 switches needed. Then clamping diodes. So how many clamping diodes is needed? So 12 clamping diode is needed. Then yeah, what is the VA not? Okay, pace with respect to the neutral voltage, what is that one? Okay, and then concern switches, what about the turn on the switches? So SA1 to SA4, it will go to, it will 3 from upper, 1 from lower, 2 from upper, 2 from lower, or 1 from upper, 3 from lower, like that one switches it will going to turn on. Okay, the next one, flying capacitor method. Capacitor method is used coming here. Okay, switches. Okay, switches you will going to use. Switches, what is the purpose? On off purpose. So correct sequence you will going to select the correct sequence to, you will going to produce the desired output voltage. Desired output voltage you will going to achieve. So capacitor is indicate the voltage level between the clamping point. So that is the capacitor is indicate the voltage level of the clamping point. So CA1, CA2, CA3 inner loop balancing capacitor for that base A. Okay, independent of the base B. Yes, so here is a C1, C1, C1 and a C2. Okay, that one is the inner loop of that. This is a capacitor for that base A, inner loop for that base A. It is independent from that one for the base B. And similarly VA naught. So M level is used, M for that level including the reference. So output line is equal to, so VAB is equal to 2M minus 1. So staircase type of the waveform it will going to produce. Then another one, last one is a cascade multi-level inverter. VA is obtained, output voltage is you will going to obtained. Okay, you will going to by adding the 4 individual output. Yes, it's a 4 individual output. It will going to see that one. So first one, and then second one, third one, fourth one. Like about individual of the output, it is coming to the across to the load, across to the load. So that is about the cascade multi-level inverter. So by controlling the switches, you will going to control the switches. So instant and conducting angle of the different transistor method. Okay, different of that. You may selected about MOSFET or IGBT. So that any type of switches you can use. So controlling the switch instant and conducting angle, you will going to base. You will going to produce the pure waveform. So it is a method you will going to use to minimize the harmonic distortion. Okay, it is a harmonics level is less than 5 percentage. Okay, few more point we're going to discuss about that each method. Neutral point clamped method. So what is a neutral point clamped method? This is a neutral point clamped method or diode. Okay, diode clamped method. Okay, diode clamped method. So instead of the diode they are using for the capacitor, but here is a not connected neutral. Neutral is not touched. Okay, so this is about the difference between this method and this method. So this is a diode. Two diode is there. The center point of the point is connected to the neutral. So diode is replaced into the capacitor. That's all. Okay, neutral point will go to or diode clamped. Okay, multi-level inverter or neutral point clamped inverter. So here we're going to see high power application. It is used for that one. Yes, it is high power application. Better harmonics reduction. So harmonics reduction is it will going to reduce. So associated control strategy and minimize the switching conduction losses is will going to minimized. Okay, it will going to minimize. So each leg, how many legs they are used? 3 legs is used. Okay, one per phases. So each containing for that two okay series connected okay high side switches and 2 series connected low side switches. Yes, 2 high side switches and 2 low side switches. These 2 high side switches and 2 low side switches is there connected. Yeah, 2 high side connected switches and 2 low side connected switches. Okay, clamp diode are the placed between the capacitor midpoint and the 1/4. Okay, that is yes, diode is the point is connected to the midpoint. Okay, then you have comparisons. So neutral, okay, I mean neutral point clamped, or you can say diode clamped method. So this inverter it will going to produce the harmonics level voltage. What is that one? 22 percentage, and then 32 percentage only it is produced. The same, okay, you will going to operate for that okay, 2 level inverter means what about their harmonics level 115 percentage. So this is a harmonics level. So that much of the level comparatively it is reduced. Similarly, what is the losses? Switching losses. If switching losses for that 2 level inverter means 25.51 percentage switching losses, it is losses, it is gone. Okay, then if I have used for that diode clamped or another name is in a neutral point means the switching losses are only for that were 2.1 and 2.2 level only. So this is about the neutral point. Yeah, neutral point clamped, or you can say about the diode clamped method. This is a MATLAB simulink of the model. The next one is a flying capacitor. Flying capacitor, as similar to that capacitor is connected across to the source, and one more capacitor is connected between this point and this point. So this capacitor is called a flying capacitor. So this is also high power, high voltage and low distortion, harmonics distortions type of that one. Okay, C is called a flying capacitor, okay, for clamping the voltage across the semiconductor devices. Okay, the topologies consist of what that one diode, what is there in the topology, it is included. Okay, it is the about that switches is there, and capacitor source like it is there. So each switches across you have anti-parallel diode is there, each switches across anti-parallel diode is connected. Okay, designed to give for that infinity levels. Okay, theoretically so although theoretically this topology has been designed to give for infinity level, but when you have go for that practically it is a limitation. So only give up to that 6 level of the voltages, the voltages is 6 levels only, it will going to effectively it will going to give. Okay, each leg is consisting of the switching devices which are okay, generally about that control switches. Yes, each leg is 4 switches is used, control switches. Okay, the inverter limb or leg consists of that cell connected to that invert nested series. Okay, see that one, this type of series, okay, seriously S1 S2 is seriously connected, so invert nested series connections. So every cell has the single capacitor. Yes, so single capacitor is every leg you have that one, single capacitor is you have used. Okay, two power switches, so it will going to, okay, between the two power switches it will going to connected. Yes, power switches is a combination of the transistor connected and with the anti-parallel diodes. Yes, so every switches is a anti-parallel diode is there. So you have noticed, see that one. Okay, even simulation also, when you have see that ready-madely nowadays it's coming, the switch across for that one diode is there, the diode for that one is a feedback diode, it is a anti-parallel connected to that every switches. Okay, power switch is a combination of the transistor connected with the anti-parallel diode. So unlike the okay, diode clamped inverter, this topology uses the capacitor for clamping type of method. So N cells is a multi-level inverter, it can give for that N plus 1 voltage levels. So N cells of that one you will going to give N plus 1 voltage level, it will going to give. So capacitor is where you are going to connect it. Capacitor is near to the load, you are going to connect it means lower voltage. Capacitor is connected to the source side means it is higher voltage. The number of level is depend upon the number of the conducting switches in the each leg. So level, okay, how many levels you want to, either 3 level, 5 levels. So number of level is depend upon the number of the switches on each level, sorry, each leg you will going to use. So it is known as another name, it is called the imbricated cell inverter. Okay, see here, and then yeah, so when S1 is on, see S1, when S1 and S11, so S11 here and S1, it is called complementary to each other. Complementary means when S1 is on, S11 is off, vice versa means when this is on, another one is off. Similarly, S2 and S21, this is also complementary. So S2 and S21 are the complementary. So one is on, another time off. When this is on, this is off. Like it is going to operate. So one from that out of the two, one from upper, one from the lower, it will going to working. So it will going to work on that one. Okay. And then C2 is a flying capacitor that provides the multi-level voltage ability to the converter. Okay, next one is a catch bridge multi-level inverter. It's a very simple. Okay, cascade is nothing but a cascade means nothing but it is a seriously connected. So seriously connected on the inverter. So seriously take the 3 inverter seriously connected, that is it will going to come as an H bridge inverter. First one output to the second one input, second one output to the third one input, and the third one output directly can come as an output. So like about that one, you will going to develop about the H bridge inverter. It's a very simplest one, H bridge inverter. So that's all about the multi-level inverter. You can look about that H bridge inverter. So there is this is one. So inverter number 1, inverter number 2, inverter number 3. Okay, 3 single phase inverter is used. So seriously connected. Similarly, you can do for that 3 phase inverter also. So that's all about multi-level inverter.